In this video, we are going to explore the ARM processor modes in microcontrollers and IoT. Let's recall the last class topic, that is ARM processor memory organization. In that, we discussed the importance and focus areas of memory organization, architecture overview, memory maps, and endians like byte ordering in little endian and big endian, memory alignment, assembly instructions like load store instructions. And today's topic, we are covering the 4 key areas like ARM processor modes overview, the current program status register, that is CPSR, user mode, the default playground, SVC mode, the OS gateway, IRQ mode, that is handling hardware events. Now let's move on to the ARM processor modes, understanding system control. We think that, so why are processor modes so important? They create differential execution in different environments, and this separation is the bedrock of system security and stability, ensuring that the user application cannot accidentally or maliciously crash the entire system. This is absolutely essential for any operating system to function correctly. Now, let's move on to the brainstorming stage of the DT design thinking. Why modes matter? Your phone OS. Let's make this real with a familiar example. Your smartphone. In nowadays, everyone having the smartphones. We know that how the smartphones are working and how the apps are crashed in every seconds. Have you ever noticed that when a game or app crashes, your entire phone doesn't freeze? We know that this is processor modes in action. Apps run in restricted user mode, which limits their access in a sensitive hardware. The operating system kernel running in privileged modes acts as a protector, isolating app failures and safeguarding critical resources to prevent total system failure. And the ARM processor modes overview. The ARM modes are broadly split into 2 categories. That is, the first one is a privileged mode and non-privileged modes. The privileged mode is which have full access to all system resources, and the single is non-privileged mode known as a user mode. In the ARM 7 profile, there are 7 core modes, that is a user, FIQ, IRQ, supervisor, abrupt, undefined, and system modes of operations. Now let us see the defined stage of DT, the current program status register. It is nothing but the CPSR. The CPSR processor state, it is the key controlling and identifying the current mode of the current program status register or CPSR. This special register holds the processor state, and it is a critical fields include the mode bytes, which is select the active processor mode, the 1 and F bytes. For disabling interrupts, and the T bit is which indicates whether the processor is executing standard ARM or compact thumb instructions. Now let us see about the user mode of it is the default playground. In this brings us to user mode. This is the default and non-privileged and most restricted mode. It uses the most restricted mode and All user applications like games, browsers run in this mode. It cannot directly access hardware peripherals or protected memory. It ensures the system stability against so many applications. This restriction is what ensures that the app doesn't bring down your whole system. And the next one is the SVC mode, that is the OS gateway, that is the operating system gateway. When an application needs to perform a privileged actions, so it is a privileged actions like writing a file, it must request help from the operating system. This is done through a system call which triggers to switch to supervisor mode or SVC. This is a privileged mode acting as the OS gateway. It handles critical operations like memory allocation and file IOQ and providing a controlled and secure transition from the restricted user mode. And next one is a IRQ mode. It gives the ideate or defined stage of DT. So the IRQ mode handling hardware events, that is like interrupt request, process hardware and kernel IRS. For responding to external events, we have the IRQ mode. This is another privileged mode decided to handling a general purpose interrupt request from hardware devices. Like we know that a keyboard press or a timer tick. When an interrupt occurs, the processor switches to IRQ mode to run the kernel's interrupt service routine, ensuring a timely and organized responses to hardware events. And the next one is a ideate or kernel role play. We know that. Let us see how these modes work together. Imagine an app. User mode wants to save a file for the first one. It makes a request. Then the OS kernel switches to SVC mode. And the third one is, it is a privileged access. It is a privileged mode. It performs the actual disk write. Fourth one is it returns the control user mode and app continuous, completely unaware of the privileged operations that just occurred at its behalf. And the last one is a prototype stage of the DT design thinking. The prototype entering a IRQ mode concept. That is, how do we enter these modes? For an interrupt, the process is automatic. We know that. A hardware trigger causes the processor to save the that is the current program status register, that is CPSR, switch to IRQ mode and jump to a specific memory address to run the interrupt a handler. We know that the programmatically a mode change can be done with an instruction like we know that MSR CPSR 0x12 and the 0xD2 is the address are Indian, big Indian and little Indian addresses, where the value 0xD2 corresponds to the configuration of IRQ mode. The last stage is the test and conclusion. So the test and conclusion, we know that it is a quick test. It is a quick MCQ test. Which mode handles general hardware interrupt? The answer is, we know that it is a IRQ mode. Let's come to the conclusion part of this video. In conclusion, The ARM processor mode are foundation for secure and stable computing. By creating differential access levels, they ensure robust operation, which is absolutely critical for modern operating system design and functionality. So now let's move on to the mind map portion of this video. We are enclosing the ARM processor modes, that is we discussed about the purpose and importance, mode categories, ARM 7 core modes, that is 7 core modes, and key modes details, and current program status register. These are the references for this video. Thank you.